Hi everyone, welcome to my YouTube channel. Today we are going to look at gravitational field. When you hear this word gravitational field, it will make you to remember what is said to be what? Gravity. What is gravity? Have you heard this saying that anything that goes up must surely do what? Come down because of the force of gravity that acts on it. So we are trying to say that any object that has mass and occupies space, gravity will act on it. And we remember we have these two types of forces. We have contact forces and non-contact forces. Contact forces are those forces that are in contact with the body to which they are what? Applied. For example, push, pull, tension, reaction, friction, and so on and so forth. But non-contact forces, they don't need to be in contact with the body to which they are what? Applied. For example, we have gravitational force, magnetic force, and electric what? Force. Under this concept, you now have what? Gravitational force. But you're looking at the field itself. So let's look at what is what? Gravitational field. Gravitational field is a region of space around a mass in which the gravitational force of the mass can be felt. So any region in which we have mass, we can say that what? Gravitational force can act on it, especially when it is in the universe, in the space, like the earth, the sun, and the moon and other planets. They are in the universe, so we have gravitational force attraction between them, even when they are what? In the space. Gravitation is the force of attraction exerted on a body on all other bodies in the universe. Gravitational forces act between all masses and hold together planets, stars, and what? Galaxies. So we are trying to say that all the bodies in the universe is being acted upon by the what? The force of what? Gravity. And this force of gravity, we have acceleration in which it works. Acceleration due to gravity, see, is a constant and is given as what? 9.80 meters per second square. So when you look at these bodies in the universe, we have the sun, we have the galaxy, we have the planet. There is actually what? A force that connects these objects together, because this object or this body of masses, they have different objects, they have different masses, and they are in the universe. There is a force, that proportional to the product of their masses and also inversely proportional to the square of the distance separating them, which was proven by Sir Isaac Newton, and he generated a law which is what we call the law of universal what? Gravitation. So you're going to look at this law and see whether you can apply this law to solve what? Problems, to see how this force affects the different masses of objects in the universe. Stay tuned. Sir Isaac Newton proposed a relationship between the gravitational force of attraction between two masses and the distance between them. And he stated the law of universal gravitation. So let's look at what the law is trying to say. The law of universal gravitation states that every particle in the universe attracts every other particle with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. What is it trying to say? For example, I have this particle in the universe. I can call it the sun. And I have another particle. I can call it moon. Okay? No, moon is small. I can call it moon. Alright? Now, this particular sun has its m mass, m1. And moon has what? Its own mass, m2. And there is a distance between them, which is what I call what? R. So he said that there is a force that is proportional to the product of the masses of this particle in the universe. That is, the force is proportional to the product of the masses of this. That is equals to what? Proportional to m1, m2. And the force is also inversely proportional to the square of the distance separating them. So the square of the distance separating the sun and the moon is r. Okay? So it means that it is over what? R what? Square. Do we understand? So the law say that the F is directly proportional to the product of the masses m1, m2, and inversely proportional to the square of the distance separating them. That is over what? R what? Square. Hope you get it now. So in every law, we are expected to generate a formula. We have this proportionality sign. So we are to remove it and introduce a constant, and certainly use it to solve what? Problems. So let's see how we can use this equation to generate a formula and use it and solve our what? Problem. Stay tuned, but don't forget to memorize the law of universal what? Gravitation. So looking at the law of universal gravitation, that states that what? F is proportional, directly proportional to m1, m2, and inversely proportional to the square of the distance separating them. So let's look at what we have. We are going to remove this proportionality sign and introduce a constant. Okay, so we have F is equals to, we are going to introduce a constant G m1 m2 over r what? Square. Okay, what is this? F is gravitational force. Okay, where F is what? Is the force, gravitational force, measured in Newton. M1 and M2, their masses measured in what? Kilogram. Then R is distance. Distance measured in what? Measured in meters. Now, looking at what we have to know that what is G. G is what is said to be what? Gravitational constant. So G is equal to what? Gravitational constant. So I want us to get the value of what? G. How do we get the value of G? By equating this and making G the subject of what? Formula. So let's go. F is equals to gm1 m2 over r what? Square. If I want to make G the subject of the formula, I'm going to say this is over what? 1 cross multiply. So I have gm1 m2 is equals to what? Fr what? Square. Okay, so I'm going to divide both sides by what? M1 M2. Okay, so I have M1 M2, M1 M2. So G is equals to Fr square over what? M1 M2. So let us get the unit of what? G. Unit of G. Okay, force is measured in Newton. I have Newton. Radius is measured in meter. Meter square over mass is measured in kilogram. I will not say kilogram square because there are two masses. Kilogram square, right? But when you're writing our unit, this one is going to come up to carry a negative what? Sign. And the value of G is 6.67 times 10 raised to the power minus 11. Okay, so I will now say unit of G is equals to, or rather value of G is equals to 6.67 times 10 raised to the power minus 11. Unit becomes what? Newton meter square per kilogram square. 6.67 times 10 raised to the power minus 11 Newton meter square per kilogram square. Okay, so with this we can actually solve problem, or we can actually solve for the gravitational what? Force, knowing that G is constant. If you are giving the masses, we already know G. If you are giving the masses m1 m2 and distance separating the two objects in the universe, so we can actually get the gravitational force between them. So let us look at an example so that you can understand what I mean by that. Stay tuned. Okay, so let's look at this example on the board. Two 5.0 kg spherical balls are placed so that their centers are 50.0 centimeters apart. What is the magnitude of the gravitational force between the two balls? Given that G equals 6.67 times 10 raised to the power minus 11 Newton meter square per kilogram square. So looking at this, the first thing is for us to state our what? parameters. So let's set our parameters. Okay, so we have solution. If they say two 5.0 spherical balls, that means they are two different balls but they have the same mass. Okay, so it means m1 is equals to what, m2, and they are the same mass, which is what, 5 what, kilogram. Okay, then the distance between them is given as what, 50.0 centimeter. So r is 50 what, centimeter. Remember that radius, or the distance, is measured in meters, so you're going to convert it to meter by dividing by what, 100. Don't forget that. So we have, this is 50 over what, 100. What do I have? 0.5 what, meters, right? Okay, my g is constant, so g is 6.67 times 10 raised to power minus 11 newton meter square per kilogram square. So you're looking for the force, and the F is what, unknown. Okay, so let's use the formula for gravitational force. F is equals to gm1 m2 over r what, square. What is my g? My g is 6.67 times 10 raised to power minus 11 times 5 times what, 5. Okay, so what are we going to do? We divide both sides by what, 0.5. remember to put what, square, to square it. Okay, so let's divide and see what we have. Okay, so we have, so if with the help of your calculator, 6.67 exponent minus 11 times 5 times 5. Okay, so I'm going to have is equals to 1.667 times 10 raised to power minus 9. Okay, divided by, let me square this, 0.5 square is going to give me 0.25. All right, so let's divide all through and get our final answer. All right, so we have 1.667 exponent minus 9 divided by 0.25. Okay, so what do I have? Okay, I have my answer to be 6.67 times 10 raised to power what, minus 9. So this is how I can get my gravitational what, force. So if you have such problem, just state your parameters, and mind you, your radius must be in meters, or distance must be in meters. So if this distance separating them is in centimeter and you did not convert it to meter, you're going to get a wrong answer. So don't make mistake. Okay, so if you square it, you're going to have the, by the time you divide, make sure you know how to use your calculator very well. By the time you divide, you're going to get what, the F as 6.67 times 10 raised to power minus what, 19. So this is how we can solve such problem. If you are watching this channel for the first time, please, I want you to subscribe to this channel for more educative videos, and also when you subscribe, other people can see it and they can also learn. Okay, stay tuned in my next class. I'm going to put up an assignment and you are expected to solve it and drop your answer in the comment section. See you in my next class. Bye.